Hello, everybody. Here we are, 8.2, modeling and solving linear systems. I have some notes typed out, so if you could start by writing those in your notes section, and I'll give it a pause. Okay, so hopefully you've written those down. Just a few things, a point of intersection, so a point at which two lines touch or cross. This is often this is our solution to the linear system. System of linear equation. This is two or more linear equations involving common variables. That's what we're looking at these days. And a solution could be a point of intersection. So it could be, if we're, graphing it, here's our graph. Let me do that better. Here's our graph. And here are our two lines. The point of intersection would be a solution to this system right there. An ordered pair that satisfies both equation, could look something like, 2, 3. So maybe our system is that, x plus y equals 5, and maybe it's that x times y equals 6 or something like that. Though these aren't linear relations, but you'll get it. It satisfies both. And our last one, a pair of values occurring on a table in the tables of values for each equation. So if we had, tables of values for each x and y, they would, satisfy both at 16 and 18 and 16 and 18, whatever it is. They would occur in both sets of tables of values. So let's look at our first one. Modeling is usually creating an equation from a word problem. So each situation and solve using systems of linear equations. The sum of two numbers is 13. Okay, so let's see, x plus y equals 13. And the larger number exceeds the smaller number by 3. So we would have our x plus 3 equals y. So maybe I could have, maybe it'd be better, I don't know if it helps if I use, smaller plus larger, and the smaller plus 3 equals larger. So let's see. The sum of two numbers is 13. So I've now represented it by small s and l for small and large. You could do x and y, so they equal 13. All right, that seems to be true. The larger number exceeds the smaller number by 3. So the smaller number plus 3 is going to give us the larger number. And now we can graph this. We can put them into slope-intercept form. I'm going to actually make a table of values for this one. So let's do S and L. Let's do S and L. So I'll do the table of values, and then I'll also graph it. So our smaller plus our larger needs to equal 13. So 1 plus 12, 2 plus 11, 3 plus 10. Let's do 4 plus 9, 5 plus 8. Let's see if this gets us a solution yet. Let's do 1 plus 3 is 4. Let's do 2 plus 3 is 5. Let's do 3 plus 3 is 6. Let's do 4 plus 3 is 7. Let's do 5 plus 3 is 8. Okay, and now we've done it. We found this is just like I said right here, a pair of values occurring in the tables of values of both equations. So we have a solution right here. And let's graph it. So let's do S plus L equals 13. A good way to start with ones like this is to start with your X and Y intercepts. So if we have S and we have L, when S is 0, L is going to be 13. So when S is 0, L needs to be 13. And that would be true that if L is 0, then S would need to be 13. And then we just need to connect all the ones in between there. That means that when S is 1, here's our other dots that we just graphed. They look like this. So they equal 13 at all spots. We're just connecting all of these dots all the way. So we knew that we had a dot here. We knew that we had a dot there. That's like finding the x and y intercept and then connecting them in between there. And then let's do the next one. I'll do it in another color. So it looks like we have points at 1, 4. Looks like we have a point at 2, 5, 3, 6. And then you can kind of get the idea. Looks like it's going up like this. And here's our point of intersection. And here, and here, and here. Let me draw that a little bit better. I'll use a different color. So there, there. And that's the point at which they cross at 5, 8, which now this is, as I said, up here, an ordered pair that satisfies both equations, and we can check that it satisfies both equations. And we've also shown a point of intersection on the lines. You don't usually need to solve it in 3 ways, but here's 3 ways that you could do it. Here's how you can go from the equation. You could put this in slope-intercept form and graph it. I chose the table of values. It's up to you. We'll also see in this chapter, they say you can use technology. So I'll show you a few on Desmos as well. And let's just check if it's true. Is it true that 5 are now our point, our x and our y? Is it true that 5 plus 8 equals 13? Yeah, I would say that is true. I say 5 plus 8 is 13. And now we can also say, is it true that 5, so I'm just inputting it into our small value, plus 3 equals the large one, 8. Is it true that 5 plus 3 equals 8? Yes, it is. So you can be confident that you answered those correctly. Okay, let's do the next one. I'll graph this one, I think, again, and then maybe for the last one, I'll show you a few ways and maybe show you the technology way or maybe confirm this next one on Desmos. So Jim has a mass that is 10 kilograms less than Terry. So looks like we go, there's a few ways I guess you could do this. Jim has a mass that is 10 kilograms less than Terry's mass. So I suppose you could go Jim plus 10 equals Terry. You could also think about this as Terry minus 10 equals Jim. Those are both true. So let me just confirm, though, that I've done this correctly. And maybe I'll actually use the other version. Let me write them both. So Tim minus 10 equals Jerry. And that's really, kind of the same version of this. If I just subtract 10 from each side, it's over on the other side. So you could use either of those. And together they have a mass of 90 kilograms. So no matter how you look at it, Tim plus Jerry equals 90 kilograms. Okay, so let's plot this. I'm going to do steps of 10, I guess. Maybe let's do 5. Is that going to make us there? 10, 20, 30, 40, 50, 60, 70, 80, 90. And let's do the same at the bottom. 10, 20, 30, 40, 50, 60, 70, 80, 90. I've chosen these values. I chose this chart when I was making these notes. I didn't have us into minus because you can't be minus weight. Very likely you're not even 10 kilograms either because then you be a small child. I don't know, but I guess Jim and Terry could be children, but it seems like they got adult names. So let's maybe start with the kind of quote X and Y intercepts. Let's put Terry here and Jim here. So this needs to be true that if Tim weighs nothing, then Jerry needs to weigh 90 pounds because they need to add up to 90. And if Jim weighs nothing, then Terry has to be 90 pounds. And then we can connect the dots in between. So it looks like we'd have dots all the way here connecting those two. If I had a good way to do an exactly straight line, I would do that, but I don't. So I'm just connecting all the dots in between. And you'll see it's true that this is where we have 80 and 10, that equals 90. 15 and 75, that equals 90. 20 and 70 equals 90. So all of these dots equal 90. And then our next part of the equation, let's think about our J is our Y. So let's plot this one right here. And for this one, I guess we could think about this in slope intercept form, though we don't really need a negative 10. So let's maybe just start where we go. Let's do a table of values again, actually. I don't want to start way down here, minus 10. So let's make a table of values for this. So Terry minus Jim, let's start him at, 70 kilos. 70 minus 10 equals 60. Let's do 60 minus 10 equals 50. Let's do 50 minus 10 equals 40. And let's do 40 minus 10 equals 30. And let's plot these points. So we have a point at, here we go. Terry is 70 and 60. Point up there. Let's do another color. Okay, so we had 70, 60. Let's do our next point at 60, 50. Let's do our next point at 50, 40. Oh, and you see we'll have a solution. Let's still do another one, 40, 30, right there. But our solution, which we got to beautifully, is at 50 and 40. So when Terry weighs 50, Jim should weigh 40. And let's see if that's true. Let's see if we did that correct. Let's plot it back in and see if it's true. So is it true that Tim 50 minus 10 equals Jim equals 40? Is it true that 50 minus 10 equals 40? Yeah, it is true. So it looks like we did that one right. And our next one, is it true that Terry 50 plus Jim 40 equals 90? Is that true? It is true that 50 plus 40 equals 90. So we can be sure we did that correct. And now I'll plot it into Desmos. That's just another way to solve it. You might have this on your calculator and your phone, so you can do this. Let's do our t subtract 10 equals j. I don't think it's going to let us use other variables, so let's do x subtract 10 equals y. And that was our intercept at negative 10 that I didn't want to do. That's why I did our table of values. So we should be looking something like this. Let's zoom out. I think I did it to about 90. And then our other one, I think, is that x plus y equals, they needed to equal, was it 90? Is that what it was? Yeah, there we go. And then we can see, do we have the same point of intersection? To zoom in, looks like we got a point of intersection at 50, 40, and that's what we got on our chart as well. Okay, so let's do this last one. Maybe I will do this one on technology, maybe not. Graph it as well. So our last one, a bag of coin contains 26 nickels and dimes, okay? So what we know is that nickels plus dimes equals 26. The value of the coins is $2.40. Okay, so what do we know about a nickel? I know we could do 0.05, that's 5 cents times nickel, plus 0.10, that's 10 cents times dimes, is going to equal $2.40. Okay, let's do this one first, and then I'm going to put this one in slope intercept form. So let's put our nickels here and our dimes here. And so we know that if we have 0 nickels, we're going to have 26 dimes. We know that if we have 0 dimes, we'll have 26 nickels. Okay, and we can point every dot in between. Okay, where am I? I feel like I'm off one already. There we go, there we go, there we go. cutoff. I was painstakingly plotting this right here and hoping that I wasn't somehow one off. But I don't think I am. There we go. And then the next one, I'll put this into slope-intercept form. I have our d on the y-axis, so let's move the n over. So I'm going to subtract 0.05 n from each side, plus 240. And then let's divide by 0.1 and divide by 0.1. And we get that d equals negative, oh, that's going to be negative 1/2. I can show you that. 0.05 divided by 0.1 equals 0.5, and it was a negative, so negative 1/2. I'm going to keep it as a fraction, easier to graph. And then we also have 2.4 divided by 0.1, which I think they give us 24. Yeah, n plus 24. And then let's plot this guy. We have y-intercept, or in this case, d-intercept of 24. And then our slope is negative 1 over 2. Negative 1 over 2. Looks like we already have our point of intersection. But let's do a few more. So it looks like right there. Let's do a few more. Down 1 over 2. Down 1 over 2. Like this. Like this. So it looks like, though, we have a solution at 422. So it looks like we need to have 4 nickels and 22 dimes to satisfy this. So is it true that 4 plus 22 equals 26? Yes, that's true. And the next one will be, I think, the real confirmation here. Is it true that 0.05, 5 cents times 4, plus 0.10, 10 cents times 22, does that equal $2.40, not 50 cents? And then I'll also graph this guy quickly. Okay, so is that true? Let's do 0.5 times 4. That's not it. This one. 0.05 times 4, 20 cents, 0.20 plus 0.10 times 22. So those are our dimes, $2.20. Does that equal $2.40? Yes, I would say that it does. So we confirmed that we did it correct. And just briefly, I'll show you our equations here. Remember, we had our x plus our y, so our nickels plus our dimes equaled 26. And we had 0.05 times our nickels plus 0.10 times our dimes equaled $2.40. And we should have a point of intersection where we did before. I think there's a way of finding exactly, and maybe if I hover over it, yeah, there you go, 422. And that was our answer. Okay, thank you so much. I'll let you know what textbook questions I'd like you to do.